Okay, ladies and gentlemen, today we are working on solving and graphing absolute value inequalities. So what you'll notice that we're focusing on that's new today is absolute value. And I bet that sounds a little scary, but if you stick with me and you concentrate, we can get through this together. This is a hard lesson. We will spend a couple days practicing it. Don't stress out yet. Just bear with me. I know you can do it. All right, so here we go. Let's start with remembering what absolute value means. So if you have the absolute value of x equals 7, that means that whatever is inside that absolute value sign could be a positive or it could be a negative 7. Because the absolute value of 7 is 7, and the absolute value of negative 7 is 7. Okay, so what if we talk about an absolute value inequality? Because that was an equation. So if absolute value is the distance a number is from 0, let's think about what the absolute value of x less than 7 means. Let's draw a number line to help us visualize this. Okay, so what numbers could x be? Well, what is less than 7? If I put in x equals 7, is that going to work? No. What about x equals 6? Absolute value of 6 is 6, which is less than 7. Okay, what else will work? X equals 5. X equals 4. X equals 3, 2, 1, 0. All of that will work, right? What about the negative numbers? What if x was negative 1? The absolute value of negative 1 is positive 1, and 1 is less than 7. Okay, what about x equals negative 6? Absolute value of negative 6 is 6, which is less than 7. What about x equals negative 8? Absolute value of negative 8 is 8. Is 8 less than 7? No, it's not. So we are looking at numbers from negative 7 to 7, but not including, so open circle there. So that is anything in between negative 7 and 7. And what kind of compound inequality does that look like? Does it look like an and or an or? If you said and, you are correct. So this is really important to keep in mind. Now if we think about the absolute value of a number greater than 7, what numbers are going to work for that? So let's think about it. Will 7 work? Is 7 greater than 7? No. What about 8? Is the absolute value of 8 greater than 7? Yes, it is. So we're shading to the right there. Okay, so let's look at the negative side. The absolute value of negative 7 is 7. Is that greater than 7? No. What about negative 6? The absolute value of negative 6 is 6. Is that greater than 7? No. So let's try in the other direction. What about negative 8? The absolute value of negative 8 is 8, which is greater than 7. So we're shading in this direction. What kind of compound inequalities does that look like? If you said or, you are correct. So let's summarize some of this and what this means. Absolute value inequalities that say less than are always going to be an and compound inequality. So on the other side, greater than inequalities are always going to be an or. Now this can get tricky to remember. The one thing that I have found that helps people to remember that is think about the word greater and or. They're very similar. Greater is an or, less is an and. Okay? So on this next slide, I'm going to show you the rules. Okay? I would highly recommend you take some notes on these, write them down. You're going to need to reference them a lot. This is how you'll rewrite absolute value to solve the two possible solutions. So if you're dealing with a less than, you're going to rewrite it as an and with the b, or the thing it's less than, as a negative, less than whatever is inside, oh, let me use a different color. Whatever is inside the absolute value, another less than symbol, and then again, whatever that b is, but this time positive. And we'll go through exactly how to translate these, okay? Now, the other rule is for greater than. It's the same idea, except we're using an or. You've got whatever is inside that absolute value, and this time it's going to be less than, because remember, an or is going in opposite directions, so we want it less than the negative, and we want it greater than the positive. Okay, so this gets really tricky. I will put these on the final. I will put these on your test. I will put these on your quiz. You will always have these rules to work off of because they are hard. Okay, so let's look at an example. We're going to start with the less than inequalities first. So I'm going to solve the absolute value of s minus 3 is less than or equal to 12. So because I have a less than symbol here, I'm following the less than rule. All right, let's get all that junk out of the way. So what is the a part? The a part is s minus 3. So that's what I'm going to write in the middle of the compound inequality. So s minus 3 is less than and is less than. Now, let's look for the b part. The b part is the 12. I'm going to write one negative. I'm going to write one positive. Remember, we're talking about absolute value. Always has a positive and a negative possible solution. All right, so now we're going to solve this guy. So remember, it's an and, so we're going to do whatever we do to the inside, we do to all three sides. So that gives us negative 9 is less than s is less than 15. So that means, if we graph it here, remember it's an and, so we're going from negative 9 to 15, open circles, and it's the stuff on the inside. So if I put in, for example, what's in between negative 9 and 15? Negative 7. That's a possible. So if I put in negative 7 for s, negative 7 minus 3 would give us negative 10. But the absolute value of negative 10 is 10, which is less than or equal to 12. Okay? So anything in between that 15 and that negative 9 will work in that absolute value inequality. Let's try this next one. All right, so again, whatever a is goes in the middle, and we've got the less than symbols, just like up here. And then whatever b is, we get a negative 1 and a positive 1. I just had to pause for a minute and think about that. I wonder if you guys caught that too. That negative 8, do you remember when we were talking about absolute value of something can't equal a negative 8? This runs along the same lines. Can the absolute value of something be less than a negative? Remember, the absolute value of something is positive. So no matter what number I put in for x, let's say I put in 1, 1 plus 6 is 7. Is that less than negative 8? No. Let's say I put in negative 7. Negative 7 plus 6 is negative 1. The absolute value of negative 1 is positive 1. Can that be less than negative 8? No. So guess what? You betcha. No solution. The absolute value of something can't be less than a negative because the absolute value of something can't be negative. All right, let's go on. Okay, these are greater than inequalities. So we're going to use the greater than rules. Remember, greater than means we're going to write an or. So whatever is inside that absolute value, that's our A. So we're writing A, 3y minus 3 is less than negative B, and B is 9, so we're going to write negative 9. Or we write the A again, 3y minus 3 is greater than, now we write the B, 9. So notice with the or you have one less than and one greater than. It's less than the negative and it's greater than the positive, because remember an or is going to be going in the opposite directions. We want it to be less than the negative but greater than the positive. All right, so remember an or, you're just going to solve each one separately, so we're going to add 3 to both sides. That gives us 3y is less than negative 6. Divide both sides by 3. So y is less than negative 2. Or, let's solve the other one. Add 3 to both sides. That gives us 3y is greater than 12. Divide both sides by 3. We get y is greater than 4. Graph that up real quick. We got negative 2. It's less than. We got 4. It's greater than. Definitely looks like an or. And so we are good to go there. Let's move on and look at B. It says the absolute value of 2x plus 7 is greater than or equal to negative 11. Okay, so now we need to think again. There's a negative there. What does that mean? So the absolute value of something, remember, is always going to be positive. So let's just make a guess here. What if we say x is 1? So we do 2 times 1 plus 7. That's 9. And the absolute value of 9 is 9. Is that greater than negative 11? Yes, it is, so that works. What if we try a negative number? Let's say like x equals negative 4. So 2 times negative 4 plus 7. That's negative 8 plus 7, which is negative 1. What's the absolute value of negative 1? 1. Is that greater than negative 11? Yes. So remember, the absolute value of something is always positive. And all positive numbers are always going to be greater than a negative. So guess what our solution is here? It's infinite solutions. All right, I know this has been really tricky. I just want you to give it your best shot and do some practice on it. There's 6 problems. At the very minimum, try to translate them. You can do it. We'll go over some more practice tomorrow, and I know you can get the hang of it. Good luck.